Hello dear viewers and welcome to Hevsal Times. Space is a gigantic laboratory with countless secrets around every corner. For centuries, mankind has been looking to the sky, studying the stars and focusing on the nearest star, the Sun, to unravel these secrets. The Sun is not only a gigantic fireball that heats and illuminates our planet, but also a celestial body that is constantly changing and evolving through complex physical processes. In this video, we will look at the Sun's south pole, a part of the Sun's surface that is often overlooked when studying large flares, magnetic storms, and spots, and which has recently come under the spotlight with new discoveries. After decades of trying to unravel the secrets of the Sun, scientists finally get a close look at one of the most inaccessible and mysterious regions of our star, the South Pole. In March 2025, the Solar Orbital spacecraft, a joint mission of space agencies, descended 17 degrees below the equatorial plane of the Sun and delivered these historic images to Earth. These images are not only a scientific achievement, but also provide data that could fundamentally change our understanding of how the Sun's magnetic field and its 11-year activity cycle work. Solar Orbiter is the first spacecraft to fly out of the planetary orbital plane and directly image the Sun's polar regions. The only previous mission to fly over the Sun's poles was a probe launched in 1990s, but while it took measurements of the magnetic field and solar wind, it did not have a camera to image the poles. Solar Orbital's advanced instruments such as the Extreme Ultraviolet Imager and Polarimetric and Helioseismic Imager have revealed that the South Pole is in a magnetic mass. Scientists observed that the magnetic field lines in this region are tangled and irregular. This is said to be due to the solar maximum period when the Sun's magnetic poles are reversed and the peak of the 11-year activity cycle is reached. This is the first direct evidence that the transition of the Sun's magnetic poles is more complex and dynamic than expected. The change of the magnetic poles determines the number of sunspots and frequency of severe magnetic storms. This data will improve the ability to predict the Sun's behavior. In particular, massive bursts of plasma known as coronal mass ejections can paralyze Earth's communications, infrastructure, satellites, and power grids. Understanding how streams of particles ejected from the Sun's polar regions are affected is vital to protect Earth from a potential internet apocalypse. Scientists are trying to understand whether these polar vortices trigger such bursts by bending or compressing magnetic field lines. According to solar physicist Sami Solanki, the solar orbital is observing from a critical vantage point right in the middle to this transition. This provides a unique opportunity to test the decades-old magnetic dynamo theory. According to this theory, the Sun's magnetic field is generated by the motion of plasma inside the star. The polar regions are the most important regions where this magnetic field rises to the surface and returns. Studying these vortexes could answer fundamental questions about how the magnetic field is generated. The first ever detailed imaging of the Sun's south pole marks the beginning of a new era in solar physics. This data will improve not only the inner workings of the Sun, but also space weather forecasts. Solar Orbiter's mission is far from over. It will remain in its current orbit around the Sun until December 24, 2026. With its next pass by Venus in the future, the inclination of its orbit will increase to 24 degrees, and by 2029 it will be at an angle of 33 degrees. This will allow the spacecraft to make even more detailed observations at higher latitudes. In the months and years to come, data from Solar Orbiter will continue to help scientists decipher this complex polar magnetism. Illuminating the unseen face of the Sun not only leads to a better understanding of the universe's closest star, but also allows us to make technology in our planet more resilient to cosmic storms. This magnetic turmoil at the Sun's south pole proves once again how much remains to be discovered. Thanks for watching. If you enjoyed, please consider subscribing. And as always, it was Hevsal Times.